At 2 a.m. on a Tuesday in late January 2025, a Windows user running a brand new Ryzen 7 7800X3D posted a message to Microsoft's own support forum that would end up echoing across hundreds of nearly identical threads over the following year. 2 days earlier, they had installed the newest Windows 11 update. Nothing else had changed. Same computer, same games, same workload. But the temperatures weren't the same. They were 5 to 10 degrees Celsius higher than before, sitting there in the background even when nothing demanding was running. Within weeks, that single post had multiplied into a wave of nearly identical reports. A Ryzen 7 8845HS laptop where idle CPU usage jumped from 1% to 6 or 9% overnight. An Asus TUF laptop holding steady at 59 to 70 degrees Celsius doing nothing at all. A Dell XPS spiking so hard that moving the mouse alone sent the temperature reading from 95 degrees Fahrenheit to 212. Multiple users on that same Microsoft forum described their laptops overheating badly enough to trigger a full blue screen crash, and more than one of them tested the exact same hardware running Linux instead of Windows, only to watch the overheating disappear completely, not occasionally, consistently. That is not a coincidence. That is a controlled variable, and the operating system was the variable producing the heat. Right now, as you're reading this and deciding whether to keep watching, your CPU is probably working. Not because you asked it to, not because you have anything open, just because Windows decided it had things to do. Your hardware is the one paying the price. I know how that sounds, because I thought the same thing for months. My machine was running warm. The fan would spin up randomly at the most pointless moments, sitting at the desktop, waiting for a file to open, doing literally nothing. I kept blaming the hardware. Then I actually opened Task Manager and sorted by CPU, and what I saw changed how I use Windows entirely. There were processes sitting at the top of that list that I had never launched, never opened, and never given permission to run, consuming double-digit percentages of my processor while my machine was supposed to be completely idle. These weren't sketchy third-party apps. These weren't accidental installs. These were core Windows services, running scheduled tasks, scanning files, collecting data, and phoning home to Microsoft's servers right in the middle of my idle time, raising my temperatures, spinning my fan, and quietly making my machine slower through a mechanism most people have never even heard of. That mechanism is called thermal throttling. And once you understand what it actually is, you cannot unsee it happening on your own system. Here's the basic physics. Every modern CPU is engineered to operate underneath a defined temperature ceiling, something manufacturers call the junction temperature limit. For Intel's current generation of processors, that ceiling typically sits between 100 and 105 degrees Celsius. For AMD's Ryzen line, it's generally lower, somewhere between 89 and 95 degrees, depending on the specific chip. When the processor gets close to that limit, it doesn't crash, and it doesn't throw you a warning. It quietly reduces its own clock speed to generate less heat, which means your computer becomes measurably, numerically, verifiably slower, and the whole process is invisible unless you're actively monitoring it yourself. A March 2026 analysis published by XDA developers put it plainly, noting that background telemetry services running on otherwise healthy machines can drive up power draw and push CPU temperatures up by 5 to 10 degrees Celsius on hardware that had been running fine for months prior. One user in that same reporting cycle described idle temperatures of 75 degrees Celsius with over a gigabyte of RAM consumed by processes they never opened. Windows itself hasn't hidden the scale of the problem entirely. Microsoft's own release notes for the 24H2 update acknowledge a running list of known issues, and support engineers have been responding to overheating complaints on the official Q&A forum in large enough numbers that Microsoft published its own troubleshooting guidance specifically addressing rising CPU temperatures after the update, recommending users switch away from high-performance power plans and cap their maximum processor state as a first line of defense. That recommendation didn't come from a blogger. It came directly from Microsoft's own support engineers, responding to a problem widespread enough to demand an official response. What makes this genuinely difficult to diagnose is that Windows doesn't advertise what it's doing in plain language. The process names inside Task Manager are deliberately obscure. Most people glance at something called compat_tel_runner and have no idea what it is. They see connected user experiences and telemetry and assume it must be something harmless or even important. They see sysmain consuming memory, notice the name sounds technical and official, and leave it alone rather than risk breaking something. The XDA Developers Community Analysis from March 2026 pointed out directly that users aren't given transparent descriptions of what these background services are actually consuming resources for, which makes most people understandably hesitant to touch anything. So nothing gets changed. The CPU keeps running hot, the fan keeps spinning, and the machine keeps quietly throttling itself during moments you never even notice. I spent a full week testing this on my own machine to see whether fixing it would actually make a measurable difference, or whether this was just internet paranoia dressed up as a tech tip. I installed HW Monitor, a free tool that reads the digital thermal sensors built directly into the processor, and the exact same sensors the CPU itself uses to decide when to throttle. I logged my baseline idle temperature before touching a single setting. Then, one at a time, I disabled 5 specific Windows features, restarted the machine after each change, and logged the temperature again. The results were not subtle. Across those 5 changes combined, I brought my idle CPU temperature down by a consistent 9 to 12 degrees Celsius, depending on the time of day and whatever Windows had quietly been doing in the background before I intervened. My fan, which had been spinning at a clearly audible speed during total idle, became almost completely silent. The machine felt lighter and more immediate, not because the processor itself got faster, but because it stopped being dragged down by background work being done for someone else's benefit rather than mine. That's the honest framing for everything you're about to hear. None of the 5 things I'm going to walk you through are malware. None of them are bugs in the traditional sense. They are intentional documented Windows features with legitimate purposes behind them, but their cost, measured in CPU cycles, disk activity, elevated temperatures, and the throttling that follows, exceeds their benefit for an individual sitting in front of a specific machine that doesn't need what they're offering. This is about reclaiming those cycles. It's about understanding, with actual temperature data rather than guesswork, what Windows is doing to your hardware when you're not looking, and walking through 5 specific, reversible, documented changes with a verified track record of reducing idle heat. Before we get into the changes themselves, here's one piece of context that makes every number in this video meaningful. Understanding what a genuinely safe idle temperature looks like is the difference between knowing this applies to your machine and just hoping it does. At true idle, a desktop processor with healthy airflow and clean cooling should sit somewhere between 30 and 50 degrees Celsius. That's the target. That's the healthy baseline. If you're reading numbers well above that with nothing demanding running, this is for you. Let's start with the process that generates the most complaint threads on Reddit's tech support communities, the most posts on Microsoft's own forums, and the most confused questions on hardware enthusiast sites from people who can't figure out why their machine spikes to 80 or 90% CPU usage for 20 minutes at a stretch while they're doing absolutely nothing. That process is called compattelrunner.exe, and it belongs to a Windows service that goes by 3 different names depending on where you go looking for it. In Task Manager, it shows up as compattelrunner. In the Services console, it's listed as Connected User Experiences and Telemetry. Inside Microsoft's own internal architecture documentation, it's referenced as diagtrack. Whatever name it's hiding behind on your particular machine, what it's actually doing is the same everywhere. It runs scheduled compatibility scans of your installed software and hardware, packages up diagnostic data about how your system performs, and transmits that data to Microsoft's servers on a timetable managed entirely by the Windows Task Scheduler. You didn't schedule it, you can't see it start running until it's already consuming your processor. And on the majority of consumer machines, it runs with no visible indicator that anything is happening at all. The trigger sits inside Task Scheduler under Task Scheduler Library, then Microsoft, then Windows, then Application Experience, listed as Microsoft Compatibility Appraiser. When that task fires, compattelrunner launches, and it doesn't launch quietly. Users on Microsoft's own Q&A platform have documented this specific service, consuming 100% of a single CPU core for stretches ranging from several minutes to over 30 minutes at a time. One user running an 8-core processor at 3.6 gigahertz reported the service eating up 20% of their total available CPU headroom during a window that should have been completely idle. Microsoft's own support documentation confirms that compattelrunner can spike both CPU and disk usage simultaneously, and that these spikes can persist for up to 20 minutes, specifically during startup and during the machine's first idle window after boot, exactly when a machine is already running warm from initializing everything else. A sustained 20-minute CPU spike immediately after startup isn't a minor inconvenience. It's a direct, measurable thermal event happening on a schedule you never agreed to. The obvious question is whether disabling this is actually safe. Every credible source available, including Microsoft's own documented guidance for Windows Home users, points to the same answer: yes. Disabling connected user experiences and telemetry stops Microsoft from collecting that diagnostic data from your machine. It doesn't affect your security updates. It doesn't break your applications. Your Windows license remains completely unaffected. The operating system keeps functioning in every way that matters to you as the person actually using it. The telemetry collection simply stops, and the CPU and disk spikes that came bundled with it stop right alongside it. Here's exactly how to disable it. Press Windows and R together to open the Run dialog. Type services.msc and press Enter. The Services console opens. Scroll alphabetically until you find Connected User Experiences and Telemetry. Right-click it, select Properties, open the Startup Type dropdown and change it to Disabled. Then click Stop under Service Status, followed by Apply and OK. Now open Task Scheduler by searching for it in the Start menu. Navigate through the left panel to Task Scheduler Library, then Microsoft, then Windows, then Application Experience. Find Microsoft Compatibility Appraiser in the main panel, right-click it, and select Disable. That second step is the one most tutorials skip entirely, and it matters. Disabling only the service without also disabling the scheduled task means the task can still attempt to wake the process back up. You need both steps to actually break the cycle. The second feature worth understanding requires a bit of history to make sense of, because it was genuinely useful for hardware most people simply don't own anymore. Sysmain, originally introduced as Superfetch back in Windows Vista in 2007, is a background service that studies your usage patterns over time, learns which applications you open most frequently, and preloads those applications into RAM before you open them, so that by the time you click the icon, the app is already sitting in memory and loads almost instantly. The logic behind it was sound at the time it was built. In 2007, the world ran on spinning hard drives with sequential read speeds of roughly 100 to 150 megabytes per second, and preloading into RAM genuinely papered over that storage latency in a meaningful way. The world doesn't run on spinning hard drives anymore. Modern NVMe solid-state drives read at speeds ranging from 3,500 to 7,000 megabytes per second. And even budget SATA SSDs deliver around 500 megabytes per second. At those speeds, the latency Sysmain was designed to eliminate has already vanished. Applications load from storage fast enough that the preloading advantage for most software is measured in single-digit milliseconds. Sysmain never got that memo. It still runs, still aggressively fills your available RAM with cached application data, and on machines with 8 gigabytes of RAM or less, that behavior can create real memory pressure and elevated background disk activity, all to preserve a performance benefit of a few milliseconds on storage that's already fast enough not to need it. The March 2026 XDA Developers Analysis identified Sysmain as one of the primary contributors to background system overhead, specifically on constrained hardware, including laptops that still have a spinning hard drive installed rather than an SSD. To disable it, press Windows and R, type services.msc, press Enter, scroll to Sysmain, right-click, select Properties, change the startup type to Disabled, click Stop, then Apply, then OK. Restart the machine, open HW Monitor or Core Temp, and compare your idle temperatures before and after. On constrained hardware in particular, the difference isn't theoretical, it shows up directly in the numbers. The third process produces maybe the most maddening symptom of all because it hits at the exact worst possible moment. You boot your machine, you're ready to work, and for the next 5, 10, sometimes 15 minutes, the fan is screaming, the CPU is spiking, and Task Manager shows disk and processor usage at levels that make no sense for a machine that has nothing open yet. The culprit behind a large share of these reports is searchindexer.exe, the process behind Windows search indexing. And it hits hardest at startup precisely because that's when Windows schedules the bulk of its indexing work, right when your machine is already under maximum load from booting the operating system, loading startup programs, and initializing drivers. The purpose of Windows search indexing is legitimate on paper. It builds a database of your files, their names, their contents, and their metadata so that typing into the Windows search bar returns results in under a second instead of requiring a live scan of your entire drive every time. You pay a background processing cost once to build the index, and every search after that is instant. The problem is that the indexing is never truly finished. It runs at startup. It runs after periods of idle. It runs again after updates rebuild portions of the index. And on machines with large file collections, the index itself can grow enormous. Microsoft's own official support documentation states that a typical user's computer indexes fewer than 30,000 items, while a power user might reach 300,000. And the documentation explicitly acknowledges that above 400,000 items, performance issues begin to appear, with resource problems including high CPU, memory, and disk usage simultaneously, becoming common above 1 million indexed items. A user on Microsoft's own Q&A platform described Windows Search indexing overheating their CPU badly enough to produce a full blue screen crash. And again, running the identical hardware under Linux, the overheating simply didn't occur. Same pattern as before. The hardware is fine, the cooling is fine, the operating system's background scheduling decisions are the variable. There are two ways to address this, and which one fits you depends on how often you actually use the Windows search bar. The first approach, worth trying before going further, isn't to disable the indexer entirely, but to limit what it indexes. Open the Start menu, type Indexing Options, and open that window. Click Modify. You'll see a list of locations. Windows is currently indexing, and for most people, the entire C drive is included, which is almost certainly more than necessary. Uncheck everything except the specific folders you actually search regularly, your Documents folder, your desktop, and your email store if you use Outlook. Removing the broad C drive sweep dramatically reduces the volume of work the indexer has to do, and typically eliminates the startup CPU spike entirely, without removing the search functionality you actually rely on day to day. The second, more aggressive approach is to disable Windows Search entirely, appropriate if you use a third-party search tool, only occasionally rely on File Explorer's built-in search, or if your own monitoring has confirmed searchindexer.exe is consistently one of your top CPU consumers. File Explorer's search still works without the index, just by scanning the drive live, which on an SSD is fast enough that for occasional searches the difference is barely noticeable. The fourth issue doesn't have a single dramatic process name to point at, because it isn't one thing. It's roughly 20 things, each individually small, collectively significant, and almost impossible to notice unless you're looking at the right part of Task Manager with the right mindset. Windows Background App. Permissions allow installed applications to keep running tasks after you close them, and in some cases to run tasks you never launched in the first place. These handle notification polling, data synchronization, live tile updates, cloud backup checks, and update fetching. And every single one of them costs CPU cycles and generates a small amount of heat every time it fires. The problem isn't any one app. The problem is the accumulation. That overhead can show up as micro-stutters and brief perceptible interruptions in system responsiveness caused by periodic CPU and disk spikes stacking on top of telemetry collection and compatibility scans that are already running in parallel. The apps generating the most unnecessary background load are consistent across nearly every forum thread and community report on the subject. Microsoft Edge runs a background process even when no browser window is open at all, and you can disable that inside Edge's own settings under System and Performance, where a toggle labeled Continue Running Background Extensions and Apps. When Microsoft Edge is closed, can simply be switched off. Xbox Game Bar runs background services on machines where the owner has never launched a single game. Mail and calendar poll continuously for new messages on a schedule you never set. Microsoft Teams, even after Microsoft's shift to the newer Teams client through 2024 and into 2025, still maintains background processes checking for incoming calls and messages whether or not you're actively using it. The most efficient way to manage all of this at once is through Windows Settings. Go to Settings, then Apps. Click the three-dot menu next to any application, select Advanced Options, and under Background App Permissions, change the setting from Always to Never for anything you don't need, running while you're not actively using it. Working through the entire list takes about 10 minutes, and the cumulative effect on idle CPU temperature is real, since every app you switch to never removes one more scheduled wake cycle from your processor's background workload. The fifth and final piece is the most nuanced entry on this list, and it deserves precision because the wrong version of this advice circulates constantly and causes real problems for people who follow it blindly. Windows Visual Effects and your power plan are two separate settings that interact with each other in ways that matter enormously for CPU temperature, especially on laptops and compact desktops without generous cooling headroom. Getting both right is the difference between a machine running at the temperature its hardware was designed for and one running perpetually warmer than necessary, not because of demanding workloads, but because of how Windows handles the quiet moments between those workloads. Start with visual effects. Every animation in Windows costs something. The fade when a window opens, the shadow underneath every open application, the smooth transition when you minimize to the taskbar, the translucency of the Windows 11 taskbar itself. Each one requires your CPU and, on many machines, your integrated GPU to perform rendering calculations every time you interact with the interface. On a machine with a dedicated graphics card carrying its own thermal headroom, these calculations are essentially invisible. On a machine running integrated graphics, where the GPU cores share the same silicon die and the same thermal envelope as the CPU cores, these visual calculations are not free, and they're happening constantly on every mouse movement and every notification fade. To reduce that load, right-click the Start button and select System. On the right side, click Advanced System Settings. In the Performance section, click Settings. You'll see three preset options. Adjust for best appearance, keeps everything on. Adjust for best performance, turns everything off, and let Windows Choose applies Microsoft's default. Neither extreme is ideal. Select Custom instead, and disable the specific effects carrying the highest rendering cost while keeping the ones that actually help with readability. Worth disabling: animate windows when minimizing and maximizing, show shadows under windows, show shadows under the mouse pointer, show translucent selection rectangle, and slide open combo boxes. Worth keeping: smooth edges of screen fonts, since that affects text clarity rather than interface animation, and show thumbnails instead of icons, which is genuinely useful for navigating files. Now the power plan conversation, which is where most confusion tends to concentrate. Windows ships with 3 default power plans inside Control Panel under Power Options, Balanced, Power Saver, and High Performance. On Windows 10 Pro and Windows 11 Pro, a 4th hidden option called Ultimate Performance can be added through an administrator command prompt. High Performance and Ultimate Performance both instruct Windows to keep your processor running at or near its maximum clock speed continuously, regardless of whether any actual workload justifies that speed, which means the CPU sits at high frequency generating high heat around the clock, waiting for something to do. On a desktop with a large tower cooler and generous airflow, that's manageable. On a laptop with a single fan pushing air through a thin chassis, or a compact desktop with a small cooler, high performance mode is effectively a standing instruction to your processor to run as hot as it can, whether the workload demands it or not. Balanced mode works fundamentally differently. It reads actual CPU demand in real time and scales clock speed dynamically to match it. When you're doing nothing demanding, Balanced lets the processor drop to lower frequencies, which means lower voltage, which means dramatically less heat. The moment you start something that needs full performance, it ramps back up within milliseconds, fast enough that for the vast majority of users, the transition is completely imperceptible. Microsoft's own support guidance, updated in response to the wave of 24H2 temperature complaints in early 2026, specifically recommends selecting balanced or energy-saving mode and avoiding high-performance mode as a first step in addressing elevated CPU temperatures after a Windows update. If you're on a laptop and temperatures remain your primary concern even after switching to balanced, go one step further. Inside your current power plan, click Change Plan Settings, then change Advanced Power Settings. Find Processor Power Management in the list and expand it, then find Maximum Processor State. The default in balanced mode is 100% underload, but you can cap it manually at 80 or 90% if your workloads don't require sustained maximum clock speed, and your primary goal is thermal reduction. This isn't for everyone. If you render video, compile code, or run anything computationally heavy, keep that ceiling at 100%. But for a machine used mostly for browsing, documents, and communication, capping the maximum processor state at 80% can drop idle and light load temperatures by a meaningful margin with no perceptible impact on daily performance. All 5 of these changes work best together. Disabling Compitel Runner stops the scheduled CPU spikes pushing your processor into elevated temperatures during idle time. Disabling sysmain removes the background memory pressure, forcing your CPU to work harder managing RAM than it should. Limiting the search index scope eliminates the startup thermal spike that hits hardest when your machine is already under load from booting. Setting background apps to never removes the cumulative rhythm of small CPU wake cycles that raise your average idle temperature across the entire day. And switching to balanced mode with trimmed visual effects ensures Windows itself isn't keeping your processor running hot during every quiet moment between those other events. The measurable outcome of doing all 5, based on a full week of continuous HW monitor logging on my own machine, was a consistent idle temperature reduction of 9 to 12 degrees Celsius. My fan went from audibly spinning at idle to nearly silent, and more importantly, my CPU stopped thermally throttling during background tasks I hadn't even realized it was running. That last part is what most people never realize is happening. You don't see the throttle. You don't get a notification. The machine just quietly operates at a fraction of its designed capability because Windows handed it too much background work to stay cool while doing it, and the processor protected itself the only way it knows how, by slowing down. The March 2026 XDA Developers Analysis noted that the thermal and power implications of background Windows services remain among the least discussed but most significant factors affecting laptop and mobile device users, with telemetry and background processes consistently causing devices to run warmer than they should even under light workloads. That analysis looked at modern, healthy hardware, not aging machines struggling to keep up. This is a configuration problem, not a hardware problem, and configuration problems have configuration solutions. Before you close this out, open Task Manager right now, sort by CPU, and just watch the list for 5 minutes at idle. If the top entries are Windows services you never launched, if your fan is spinning while nothing is running, if your idle temperature is sitting above 50 degrees Celsius, you've just identified the problem, and you already know exactly what to do about it. Every one of these 5 changes is fully reversible. If anything behaves differently than expected, go back into Services, set the startup type back to automatic, click Start, and the service is running again within 30 seconds. There's no real risk in trying this. There's only the possibility that your machine ends up running cooler, quieter, and at the full performance level it was actually built to deliver, instead of quietly throttling itself to guard against heat that never needed to be generated in the first place.